Hi everyone. In this video, we are going to prove a trigonometric identity that involves the three interior angles of a triangle. There are various trigonometric identities involving three interior angles of a triangle, and we are going to prove all of them in this series of videos. Today's is the first one. We are going to prove the first one in this video, and in the subsequent videos I am going to prove the other ones. If A, B and C are the three interior angles of a triangle, then from the angle sum property we know that A plus B plus C will be equal to 180 degree or pi radian, and from there we can also say that A plus B will be equal to pi minus C. Similarly, B plus C will be equal to pi minus A, and C plus A will be equal to pi minus B. And because the identity that we are going to prove here involves three angles which are kind of related through a certain condition, and the condition is that their sum is equal to pi radian. So these trigonometric identities are also sometimes called conditional identities, because the angles that are involved in these identities, those angles are kind of related together through a condition, and that binding condition is that their sum is equal to 180 degree or pi radian. Now let's take a look at this identity. Sine of 2 times A plus sine of 2 times B plus sine of 2 times C is equal to 4 times sine of A times sine of B times sine of C. And we have to prove this, right? We have to prove that the left hand side is equal to the right hand side. Now to prove this identity, we are going to use some of the basic trigonometric concepts here. The first concept that we are going to use is this one, where we know that when converting from a sum into a product, we can use this formula, like sine C plus sine D can be written as 2 times sine of C plus D over 2 times cosine of C minus D over 2. And similarly, cosine of C plus cosine of D can be converted into a product like 2 times cosine of C plus D over 2 times cosine of C minus D over 2. So that is one set of concepts that we are going to use while proving this trigonometric identity. And also there are a couple more concepts that we need to use, and the next one is like this: sine of 2 times A is equal to 2 times sine of A times cosine of A. And the other concept that we are going to also use is cosine of a negative angle is equal to cosine of the positive value of that angle, meaning cosine of negative theta is equal to cosine of theta. So we are going to use these basic trigonometric concepts to prove this identity. So let's get started with the proof. The left hand side of the trigonometric identity is sine of 2a plus sine of 2b plus sine of 2c. Now eventually we have to convert this sum into a product form, right? So first what we are going to do, let's try to convert the first two terms, sine of 2a plus sine of 2b, into a product form. And if we do that, we can write this thing as 2 times sine of 2a plus 2b over 2 times cosine of 2a minus 2b over 2, and then of course plus sine of 2c. That's the third term. We are keeping that as is, and from here we can say this is equal to 2 times sine of a plus b, because 2a plus 2b over 2, that will be a plus b, and times cosine of a minus b, because 2a minus 2b over 2, that will be a minus b, and then plus sine of 2c. And here let's look at the first factor in the first term, that is sine of a plus b. Can we write it as sine of pi minus c times cosine of a minus b, plus sine of 2c, we can write it as 2 times sine of c times cosine of c, and here sine of pi minus c is also equal to sine of c. So we can say this is actually 2 times sine of c times cosine of a minus b plus 2 times sine of c times cosine of c. And if you see here, we have a nice common factor, 2 times sine of c. That is a common factor here. So we are going to take the common factor out. So we can say this is 2 times sine of c times, I'm going to use a third bracket, and there we have cosine of a minus b plus cosine of c. Now 2 times sine of c going to stay as is, and now we are going to convert the sum within the bracket into the product form. So we can write it as 2 times cosine of c plus d over 2, that would be cosine of a minus b plus c over 2 times cosine of a minus b minus c over 2. Think about it. If you assume a minus b to be c and c to be d, so cosine of c plus cosine of d can be written as 2 times cosine of c plus d over 2 times cosine of c minus d over 2, that you can see on the top right corner of the screen there. That's the form we are using here, right? So we are converting the sum into a product. And now let's simplify this. So we can write it as 2 times sine of c, and then of course we have 2 times cosine of c plus a minus b over 2 times cosine of A minus B plus C over 2, because A minus B minus C can be written as A minus B plus C, and of course divided by 2. So now we see that we have 4 times sine of C, because 2 times 2, that would be 4. So we have 4 times sine of C, and then times cosine of C plus A minus B. Can we write it as cosine of, in place of C plus A, can we write it as pi minus B? So this is actually pi minus B, that's the C plus A, and then minus B, one more negative B is there. So in place of C plus A, I am writing pi minus B, and also there is another minus B over 2 times cosine of A minus, here again I am going to write pi minus A, because B plus C is equal to pi minus A over 2, and from here let's simplify a little more. From here we can say this is equal to 4 times sine of C, and then times cosine of pi minus 2b over 2 times cosine of, this will be 2a minus pi over 2, and from here this can be written as 4 times sine of C times cosine of pi over 2 minus b, and times cosine of A minus pi over 2, and from here we can write it as 4 times sine of C times cosine of pi over 2 minus b will be the complementary ratio, which is sine of b. So we can write sine of b in place of cosine of pi over 2 minus b, and times cosine of A minus pi over 2 can also be written as cosine of negative pi over 2 minus A, and this can be written as 4 times sine of C times sine of B times cosine of, the negative sign will disappear because we know that cosine of negative theta is equal to cosine of theta, so we are going to ignore the negative there. Then this can be written as pi over 2 minus A, and obviously this can be written as 4 times sine of C times sine of B times cosine of pi over 2 minus A, that can be written as sine of A, the complementary ratio. So we are going to write sine of A. Now I think we are almost there, so let's just reorganize a little bit. We are going to write it as 4 times sine of A times sine of B times sine of C, and that is definitely equal to the right hand side. So hence it is proved. We have been able to prove the identity. Now if you take a look at the identity, we had sine of 2a plus sine of 2b plus sine of 2c is equal to 4 times sine of A times sine of B times sine of C, and that's exactly what we have proved down below. So the proof is complete now. This brings us to the end of this video. In the next videos, we are going to prove a few more identities like this. I hope everything made sense in this video. Thank you for watching. See you in the next video.